I was just going to mention on Jack's presentation, for small telescopes, there is a solid state inclinometer that you can also use. And we've actually done that with our interferometer small dish radio telescopes. And and the beauty of that is you can just glue it to a position on the scope and you don't need any mechanics. And so for at least elevation, you could do that. For azimuth, you could actually do a gear system. So just wanted to mention that if anybody wants to look that up, there are available solid state inclinometers like you have in your phone that you can interface to a Raspberry Pi. So that's another approach. I think Jack's thing is very good though. I'm Bill Miller. I'm from the Deep Space Exploration Society. I think everybody knows what that is. I don't know if I haven't been that involved in SARA for the last 2 years because I've been too busy building our new operations center. But I don't know how much you know about us, but I'm going to give you an overview. This isn't going to really be technical at all. It's just going to be an overview of all the stuff that we're doing at Deep Space Exploration Society and our own facility. So the DSES, some people call it DSES, we own and operate a 60-foot radio telescope far out on the eastern plains near Haswell, Colorado. There's a picture of that's my Dodge Durango in the shadow, and you can kind of see how big that really is. The Deep Space Exploration Society is a Colorado-based nonprofit. We're a 501c3 organization dedicated to astronomy, the application of space exploration and radio education for students, the general public, and mostly our society members. So we're educating ourselves. We started all this with very little knowledge. Most of the members that came into this were ham radio operators, and we got into this because we had a telescope. Okay, so we strive to continuously update and improve our facility and advance radio astronomy and amateur radio capabilities. I'm going to give you some history here. This is going to be about 5 slides. The twin 18.3 meter or 60-foot radio telescopes we're in Boulder County, and we have an identical unit in Haswell, Colorado. So these were originally built back in the 60s and operated for the National Bureau of Standards and for their Central Radio Propagation Laboratory. It was to study tropospheric scatter, and this was sponsored by the Air Force, and other antenna sites were located all the way from Colorado to Arkansas. So the goal of the original research at the site was to compile accurate reference material so that anybody wanted to build a similar tropospheric radio communication system could do so with the information provided by this agency. The study of the site lasted from about 1958 to 1974. So that information gathered was to support the early communication systems for the distant early warning radar system, or the DEW line. So if you want to get high-speed data from one place to another, you need high-frequency communication, so microwave, right? And this provided a way to do that. So the Haswell site was constructed about 1957. The land was leased and then expanded and purchased by the government in eminent domain about 1963. But they were already on site doing this work. So that site was operated until about 1974, and it was made obsolete by satellite communication, fiber optics, and so it was just not, that sort of thing was not needed, and the study was finished by then. And so it was abandoned, it was surplused on government auction. This is a picture of the site in 1972. In addition to the big radio telescope, there was a 500-foot VHF television tower on the site where they did propagation studies to figure out how close they could put television stations together on the same channels. There was also 3-phase 900 amp service, electrical service on the site that powered all the high powered transmitters and everything that they had there. Now, how many people know what tropospheric scatter is? Okay, a lot of hams in the group, right? So for those that don't, tropospheric scatters where you have a station, say here at T1 location, and you point that into the horizon, that lights up a volume of atmosphere out over the horizon, out over the limb of the Earth. And if you have another station some distance away looking back at that volume of atmosphere, you can receive that signal reflected off the particles in the atmosphere and just the atmosphere itself. And so if you could actually get up to about 600 miles in one of these links. So with a minimum number of links and not line of sight, you could transmit a microwave signal over a great distance, like from Colorado to the dew line in Alaska. So now I'm going to tell you about our org. So the DSES organization, it was originally formed in 1991 in Boulder County. The members started restoring those two unused 60-foot radio telescopes that were part of this network on North Table Mountain at the T22 site. They call it T22. There's various sites up there on North Table Mountain. And they had considerable success with that. Those were unused telescopes that had been furloughed about the same time as the one in Haswell. And so they were able to get some of that working. They had one telescope completely working. They had it tracking. They were doing experiments. And unfortunately, Table Mountain is a secure government facility. And after 9/11, some of the more conservative government management said, well, we really shouldn't have civilians on the site. So they kind of threw them out. They needed to go somewhere else. Well, they knew about this other radio telescope down in Haswell, and that was dormant from about 1974 when it was decommissioned to 2007, and it fell prey to the elements and vandalism and theft of all the infrastructure, copper. All those power lines have been taken out for the farmers, so they didn't have to farm around the power lines. Sometime during that period of time, between 74 and 2007, a government contractor named Paul Plishner, he purchased this on government auction. And after purchasing it, he sent some of his people out and they looked at it and came back and said, well, there's not much you can do. There's no power. It needs a lot of work. So he put it up for sale, and he even tried to sell it as scrap because it's all aluminum, and didn't find any buyers. We've talked to several people that actually looked at it, and they didn't buy it, but didn't meet his price probably. But so it didn't happen. Well, when the DSES group left Table Mountain, they asked him, "Hey, can we come in and be the custodians of your site and try some things and see if we can get that to work since we've done this work on Table Mountain?" And he said, sure. And he gave him a no-cost lease and permission to go on site and do their thing. So they took their communication trailer, they have an aluminum van, so to speak, and all their equipment and went to Haswell, and they'd come down from Boulder and camp out on the site for, a week at a time and do various projects and try to get things to work. During that time, they got the motors replaced and actually got the unit to track off of a small generator. So they had a little 3,500 watt generator. They could start that up and actually get it to work. So in 2007, our volunteers, they've been working really hard to restore the site and the antenna and all the support facilities. And so after making some progress in 2008, Michael Lowe, who was our president at the time, went to Mr. Plishner and he says, why don't you just donate this to us? We've got things working and you could use it as a tax write-off. And so he did. He gave us, well, not the whole site, but part of it and the dish. And so for that generous donation, we named the site the Paul Plishner Radio Astronomy and Space Sciences Center. So Mr. Plishner passed away in November of 2016, but his generosity is greatly appreciated, and by the organization, and his legacy will live on for many years as we develop this site to its full operational capability. I'm going to switch gears a little bit. Here's the specification for the dish as it existed in the beginning. We've used it from 400 to 2 gigahertz. We think that 10 gigahertz is possible with some attenuation. The mesh of the dish, or the platform of the dish, is perforated. And so at some point, those holes of perforation in the dish, they're 1/4-inch holes on 1/2-inch centers, that becomes transparent at higher frequencies. But we think we can get up to 10 gigahertz with some attenuation. The diameter is 18.3 meters. The gain at a gigahertz is like 42.5 dBi. Got about a 0.8 degree beam width at 1.2 gigahertz. Wow. So that's pretty good. It has very low noise temperature. We have full hemispherical tracking control. So anything that we want to track, we have solarium. We can point at an object, say track that, and it'll go to that object and track it as long as it's in the sky.
Can I ask a question? What is the resolution of your tracking ability in terms of the dish?
I'm going to get to that next slide or so. So it has a 40 degree per minute capability on the motors. The interesting thing to me is that this parabolic dish, it was specified in the beginning to be no greater than a 1/4 inch from the true parabolic shape over the entire surface of the 60-foot dish. So that's pretty incredible. And that was even in a 30-mile-an-hour wind, and slightly reduced resolution in a 50-mile-an-hour wind. And when it's properly stored, it's capable of withstanding 120-mile-an-hour winds with I believe, a ice load of 3 inches of ice on the dish.
And that 1/4 inch deviation, that's maximum, right? So that
was the maximum
peak deviation. So
yeah.
your RMS is way better than that.
Yeah.
Yeah.
So it's interesting that what they did was they even ground on the aluminum plate. We can see grind marks on the aluminum plate where they were trying to achieve that.
Wow.
So pretty accurate. Here's a picture of the inside of the dish. This is Ray Uberek. I call him Dr. Radio right there. That guy has installed every radio station, television station on the Front Range of Colorado. And anyway, he's our main evangelist for this kind of thing and got me into it. You can see the superstructure there. It's all heliarc welded aluminum pipe. These are 10 and 8-inch aluminum pipes, and it's all welded to government specification and inspected to that. So it's just a thing of beauty when you look at the superstructure. Okay, so get into some of the things about the facility. So we have a lot of recent site infrastructure upgrades and projects. We have a new building, an operations center, new equipment racks and consoles for the dish and radio controls, kitchen, bathroom, garage, classroom, the control room and classroom furniture for larger groups. We can see quite a few people in there now. We've run PVC conduit from the building to the dish and to the Rome towers that contain our radio antennas. A 1,280-gallon potable water system tank, 500-gallon septic leach line, new utility power for better distribution loss on the site in the building. Right now we have DSL internet, which is really slow. It works pretty well. We can run 4 cameras, 4 like Nest cameras off of DSL, but we were hoping to get upgrade to fiber in 2025, but right now we're not really sure that's going to happen. That was part of the infrastructure thing. We've got our security cameras, and we've upgraded the dish power and the grounding system for higher power feed antennas that we have in the system. So, new operations center. In 2022, we wrote a grant. Dan Lane and myself, we wrote a proposal to the ARDC, the Amateur Radio Digital Communications Group, who gives, they're like an organization that has an endowment, and they have to give away so much of that endowment every year. And so most of their grants are for ham radio projects. And we were one of these ham radio projects. So we wrote a proposal and said, what we really need is a building. We've got this little communication trailer, more than 5 people get in that room and it's crowded. During COVID, if somebody would sneeze and everybody'd run out of the room, right? So what we really needed was a much better building to do this work in. So anyway, they accepted our proposal and gave us the money. And so we hired what we thought was a general contractor. It turned out not to be so much of a general contractor, more of a grounds work and concrete guy. Got our slab in and everything and kind of abandoned me. And so I took over as the general contractor and project manager and started hiring subcontractors to do the work. So we put up a metal building and hired other people to do various interior work in the building. So it's 1,800 square feet. It's much more comfortable with the kitchen, the bathroom, the classroom, everything for our students and visitors. Has a radio room and control room and much more friendly environment. Here was the original design that I did. I just used Home Designer, the simplest form of Home Designer, about $50 program to do the design. And then there's a pictorial of it. But we gave this to the metal contractor and they built us a building, and guys came out from Clovis, New Mexico, 4 guys, put this thing up in 3 days. Here's what the building looks like as it was being constructed, looking down from the service tower on the telescope. There's the finished building, and it has a driveway and a garage on the other side of these cars here. This is the service tower. You can see there next to the edge of the dish. The dish is down in service position. And then the interior of the building, we've got a kitchen, bathroom, the control room, and a classroom. Much better, much cleaner. The whole thing is spray foamed in. So one of the things we have out there is a very high wind, very dirty environment. And so the winds just blow dirt into everything. So we sealed the building by spray foaming the entire inside of the building before we put in the walls and the sheetrock. And so that really kept out a lot of the dirt, sealed the building up from not only dirt, but from all the insects and that sort of thing. So that new building is going to give us a much better operations center to do all the educational things that we want to do.
Question?
Yeah, go ahead.
Do you have your water is brought in?
Yes, we have a gentleman that hauls water from one of the communities about 30 miles away. And we pay him to bring water in and fill our tank. We just did that last week.
Thanks.
Another quick question. How far away are accommodations?
You want to just, what do you mean by combinations?
To come out. Hotel.
Accommodations, okay. Well, you can sleep in the building if you bring a cot or an air mattress and a sleeping bag. And the nearest accommodations are about 30 miles away. There's about 30 miles to Los Animas and about 35 miles to Eads, Colorado, where there's a better hotel. And it's about 2.5 hours from Colorado Springs, where I live.
Thank you.
Okay. So we do. We've got some radio and astronomy upgrades. So there's a remotely operated, all band, all mode, full power amateur radio station donated by Paul Sabone. N0T, and Paul didn't have a place for this. He actually operates the radio system out of his apartment in downtown Denver in a high-rise And he does that with his computer. It's all remote control over the internet. And so we put that in our bunker. On site at the facility, we have an underground bunker that's about 1,500 square feet. And so it's an ideal place to put the radio, keeps it cool, and the towers are above the bunker there. On the new building, we have 2 new Roam 45 antenna tower bases right now. We haven't put the towers up yet. That's the next project this summer. But so we can have about 50-foot towers next to the building for our one tower is going to be VHF, UHF, and the other tower is going to be HF. We have a 300-watt EME and a 2,000-watt EVE 1296 power amps and transverters for the dish. I'll talk about that in a little bit. Full hemispherical tracking control. We just upgraded that from a 12-bit system, which gives us about 6 arc minutes of resolution, to a 16-bit system, which gives us about 20 arc seconds of resolution, okay? Which is way more than we need with a 0.8 degree beam width at 1296 and about 0.7 at 1420. So have much better resolution than we really need. That was done by Glenn Davis, Lewis Putman, Phil Gage. These guys are guys that work on the geode space junk tracking system that's optical. So they have an optical mindset. So more resolution is better in their view, where we really don't need that for radio astronomy, but we have it now. We run an isospheric scintillation experiment with the University of Texas at Dallas. That uploads every night. That's a thing that receives the GPS signal from GPS satellites through the ionosphere and looks at the difference in amplitude as it comes through the ionosphere, and it gives us data that they're tracking to improve the GPS system and satellites. Also, the Callisto solar spectrometer experiment. We have a log periodic antenna that does that one. We have an experimental interferometer with 2 3.8 meter dishes. That one's in progress. One of them was just fell down in this big windstorm we had. And so now we've got to pour a new foundation for that and put it back up. And that's where we're going to use that inclinometer that is a solid state device. We recently acquired a 30-foot additional antenna in a silent key estate. And we're now working on getting the money to do the foundation for that, renting the crane to put that one up. And of course, we do Super SIDS, Radio Jobe, and all the other standard radio amateur experiments. We have for radio astronomy to date, we've done with the high gain antenna, we've done pulsar logging, hydrogen line, Radio Jobe, Super SIDS, meteor scatter, and even some SETI work. Rich will recognize this. This is from Rich Russell, the SARA president, where he did drift scans with the big dish and took data and plotted that in a spreadsheet and drew a map of the hydrogen in our own galaxy. And so that's an example that was done before we had all the extra tracking control that we have now. Today, we can do raster scanning and do something like this for any object, and probably do it in higher resolution. Done a lot of tracking of pulsars. I don't know if this will, I'm afraid to try this, but let's try it. Oh, here we go. That's not it.
Oh. I think it is.
blow it up.
I think the share screen is specifically on the PowerPoint.
Oh, that's okay.
So
Let's
yeah,
not do that.
take that. It's not actually showing the whole screen, it's
Yeah,
just
that's
showing.
too hard to do.
I've just minimized that. There you go. Okay.
Yeah, I won't run that one. That was just a time lapse. If you're interested in this, we have these time lapse videos of the dish in operation up on our YouTube channel. And also, one of the things to look at, one of our members, Mark Slover, is a master time lapse photographer with all his own equipment and does incredible time lapse photography. He's on Road Trip Ventures on YouTube. I had to do a commercial for Mark there. So far, we've detected 25 known pulsars. We've got the capability to track for very long periods of time. And with the 60-foot dish, we don't have to track as long as a smaller dish would have to track. We're slowly going down the list of pulsars. We have a kind of a rule. Everybody says, well, why don't you remote this like the Green Bank dish, 20-meter dish? And the problem is that we don't have the control systems and the maintenance to be able to do something like that. So we don't want to remote it. We also have a 2-person rule. You got to have 2 people on site to do anything with the dish and in general on site because there are a lot of hazards. Use the GNU radio, the GNU radio data collection and Presto pulsar folding algorithms to come up with the pulsars. We've actually also captured one maser, and that was at 1665 megahertz hydroxyl maser. You'll recognize this. This is your president, Rich Russell, in front of the console doing pulsar work back several years ago. Had a lot of interesting work doing that and spent a lot of time. There's some of the observed pulsars on the data sheets for each one of the pulsars with different timing. So we also have a remotely operated amateur station that I talked about earlier, donated by Paul Savone. It's fully remote controlled. It requires 2 monitors and 8 screens to run it. So Paul is about the only guy I know that can run the thing, but it is available to all our members. And this is located in the bunker. We have that underground bunker I was telling you about. I always tell the kids about this when they want to know what we're doing. I says, when you were 10 years old, what did you dream of, right? And I say Johnny Quest, and all look at me like, who was Johnny Quest, right? But I remember Johnny Quest, so I say, well, how about the Paw Patrol or somebody like that? They say, oh yeah. I said, well, what do they have? Well, they've got a compound, they've got a lair, right? Well, we've got a compound and a lair. I said, so you ought to come in and join us because you're going to have a lot of fun with this. So the underground bunker, that's the radio station. This is Bill Thompson in the underground bunker running the radio station. There's the 8 screens I was talking about. So, now, let's see if I can make this one work, I hope. So we do a lot of EME and contesting work, or contesting.
So I think I may have that audio turned down on the laptop.
Okay.
Sorry, let me see if.
So we've got a 100. This was done with a 150 watt 1296 transverter. And by transverter, I mean we're converting the 50 megahertz ham radio signal up to the dish, and then we translate that to 1296 megahertz. Okay, and that was a 150 watt system. And that's what we were doing our EME communication with. Most EME communication is done with digital modes because people have small dishes and small transmitters. And so with the digital communication mode, you can be below the noise floor, in fact, and still send a signal and send your call sign and your location and all that. So now we have the capability to do a little more than digital communication. We can do single sideband. And we're one of the strongest stations out there doing single sideband. So, not sure. That's okay. We can just get back. You had it.
Yeah, the problem is I had to, the direct wasn't working anymore, so I had to log in. Turn on the audio while it's logged in.
It's just a short. What I was going to show you there was I can't show you all the kids that we took videos of, but that was my grandkid, my 8-year-old granddaughter, and she got to bounce her voice off the moon. She thought that was pretty neat. What she thought was even neater is we had an old style phone on the desk. She says, "What's this?" And I said, "Well, it's a phone." She says, "That's not a phone." And I said, "Yeah, it is." I says, "Here, call your grandmother," right? And so gave her the phone and she says, "How do I do it?" And I said, "Well, it's got push buttons. You have to dial the number." So she did. She goes, "Anna?" So she was more thrilled with that phone than bouncing her voice off the moon, actually. But so what we did was we bought her a princess phone or a French phone for her bedroom. So now she's got a laminated sheet on her nightstand of all her friends that she can call on her special phone.
Take this back. Oh,
Give us a second here.
I know what I need to do.
Okay.
Bill, how many members we got in DSES now?
About 110.
What's the farthest member from Colorado?
The farthest member is in Australia. Mark, I can't remember his last name. He actually came out and met with us last fall and was pretty thrilled with the whole operation. In fact, I'll talk about that in a minute, but he was trying to get us connected with the Parks Observatory so we could do a new experiment.
Okay, why? Oh, okay, we're good.
We're good.
I just need to.
And how much is the membership per year cost?
Okay, the membership is $50 a year for full voting membership. We actually have a free student membership, and we have a non-voting membership for people that really don't want to participate much for about $20 a year.
How many members are outside the U.S. approximately?
Oh, that's a good question. We have,
And Bill?
I think we have 2 or 3 in Canada.
Bill, I can answer that question.
Yeah, go ahead.
Yeah, we
Yeah.
have Mark Drayton, and he's a ham, VK6 ham in Australia. We have Skip McCauley up in Alberta, Canada. And right now, they're the only 2 out-of-country hams. We have hams stretched from Philadelphia, North Carolina, Washington State, San Diego, and every point in between. And we also have one ham just recently, this couple days ago, from Scotland, is showing interest. He's a radio astronomy enthusiast, and he will eventually join from Scotland.
Did I finish this one? Anyway, long story short, we're one of the strongest stations on off the moon. So when we do these contests, people, in fact, we had a couple of the European groups said, "You shouldn't be allowed to participate in the contest because you have a 60-foot telescope and a whole organization behind you doing this." So they didn't think that was fair. We said, "Nah, we're good." Uh-oh. I can't run it.
Uh-oh.
We're stuck. Let's see.
Oh, you might just need to use enter and backspace instead of the arrows, maybe. It was doing, it stopped. Or is it frozen?
It's frozen. Give us a second. Should have known better. We had it working.
Yeah, we did.
We actually tested this before trying it.
Always get the time.
Oh, there you go. Now if you just go back into
Now, because you back into it, should be. And it did advance, that's fine. Well. Right there. That's where you want to be. Okay.
Hey, Bill,
Well, we can, if we get it working, we can just back.
Bill?
Yeah.
While you're waiting, would you erase that artwork? It's scary from this distance.
I thought it was pretty good.
Oh, no, it's,
Is that it? Right one?
Yeah.
How much more do you? What they're seeing out there is, what doesn't have.
Okay,
How
much more
do you have?
just a couple.
Okay.
Yeah, but I'm gonna reclaim a little bit here. Annual open house in September or October. Last year we had it in October. We're talking a little bit about making this semi-annual. It's a lot of work. We don't gain any money from it, but we might make that semi-annual versus annual. We do optical and radio astronomy demonstrations during that. We judge and make awards to the Pikes Peak Regional Science and Engineering Fairs. I just got done with that and we gave out 4 awards. I'll show you that in a minute. We do publications on radio and radio astronomy. We belong to the Society of Amateur Radio Astronomers. We have site trips and tours to the national observatories like what we're doing now. And we have a website with all of our articles and all our presentations on it. And even all the meetings, I believe, are on our website. We mentor, I can't see the bottom 2 slides, but we mentor students in radio astronomy and science projects and make presentations. During our open house, we have a 4-H club benefit. And the mayor of the little town of Haswell is about 60 people. She comes out and does a pulled pork barbecue for us and has all the fixings. We charge $16 a plate for the barbecue. Last year, we had 90 people sign up for the barbecue, and they made quite a bit of money for the 4-H club from our open house. And we got to have a lunch, and that brought more people out to our open house. This is a picture of the kitchen, the classroom, and the classroom converted for the barbecue. Also do, like I said, optical astronomy during the open house. We do site tours. We have dessert even. And then education, we do the Science Peak Pikes Peak Regional Science Fair. We just had a group from the Lamar High School come out with a busload of kids, and we gave them a seminar on radio astronomy. This is a good picture of our control room. Ray Uberek has given a presentation in the control room showing them how the dishes operated and how we do radio. We gave frameable certificates and cash awards for science fair. Won't go into that too much. And when we do public outreach with the local communities, we go to their bazaars, we go to their street parties, and then some of the guys went out to the International PME Conference in Trenton, New Jersey this last fall. Last summer, we did a GoFundMe project to raise the money to go get this 30-foot radio telescope. Robert Clark was in Ignacio, Colorado, and his wife donated his 30-foot dish after he died. If we could just pick it up and haul it away. It was destined for the scrapyard, so we said, hey, we can't let that happen. So we raised the money, sent about 8 people out there for 4 days. And they rented a crane and picked up this 30-foot dish, brought it all back. Right now, we're trying to raise the money to resurrect the dish. So we're gonna pour new concrete and get another crane. It's gonna cost about $5,000 to resurrect the dish. And when we did this, one of our members, Elaine Hamley, she wrote an article about the whole thing. She went on the trip, wrote the article, and sent it into QST magazine, and they put us on the cover of April QST magazine. So this is the DSES on the cover here.
Bill, let me ask you a question about security.
Yeah.
How do you guys maintain the integrity of the site since it's so remote and there are not always people there, right?
No, it's remote and it has a lock gate. All the buildings are locked, and we have security cameras on site, and we monitor it, and the sheriff kind of keeps an eye on it for us, and so do the locals. One of the reasons we do local outreach programs is so the locals know who we are.
Yeah.
The site, when it was vacated, people put bullet holes in the dish. And so just by having that familiarity and being part of the community, we have a little bit of safety. Okay. Now, I wouldn't say it's completely safe. So we have an engineering meeting every second Monday of the month at 6:30. We have a science Zoom meeting every fourth Monday of the month at 6:30. And so that keeps everybody connected. We have a site work trip once a month. Actually, lately it's been every week. We're going to the site almost every week to work on some of this stuff. And then to join DSES, it costs $50, like I said. And you can do that on our website, dses.science, and do it with PayPal. One of the things I didn't mention here, go back a little bit. So the latest thing that we're doing is E. Since we were so successful with EME, we're going to do Earth, Venus, Earth. And we're going to try to do a QSO, or a communication of data off of Venus. And other groups, Arecibo radar map Venus, and the Bochum Observatory in Germany, they detected their own 13-centimeter signal as a bounce off Venus, but they didn't communicate. So we're going to actually try to send a digital signal off and bounce it off of Venus and get it back. And that's really hard to do. This is the transverter that Alex Nersisian has built for us. This is a 2,000 watt 1296 transmitter, and that's up in the hub of the dish. And it's fully remote control and has all kinds of telemetry, and very hard to do. In fact, they're there today testing this and getting it ready to do this. We're actually going to try this on the 22nd, 23rd of the month to bounce a signal off of Venus. Very hard to do. These are the guys climbing on the dish to do it.
Has any ham ever done?
Hard to do. 50 million miles. You know, the moon is, you know, like a 250,000 miles away. This is 50 million miles. It's 4.5 minutes round trip at light speed. And 346 dB of loss. That's the path loss of trying to communicate out Venus. The moon's only about 283 dB. Yeah, got a question?
22nd and 23rd of this month, did you say?
Yes. Well, that's their first attempt. And then they'll continue to try that until Venus is in the sun. Right now, we're only about 15 degrees off the sun. So as it moves around and gets closer to being in conjunction with the sun, we're going to have a problem. So we'll have to wait till it comes out the other side before we'll have to try it again. There's a lot of geometry and a lot of orbital mechanics and considerations to do this because of the rotation of the planets and the rotation in the orbits around the sun.
And who has
Why not
done
a
this
Mars
and
bounce?
when?
Come back, Ted.
This before and when?
Say that again.
Who has done EVE before, and when was it done?
We don't know of anybody that's done it. No amateur group anyway.
Yeah. The two-way communication not done, just about hearing their own echo.
But they just did radar to measure the distance to Venus.
Yeah, the German radio club did it with 80-foot dish and, as Bill said, 6.5 kilowatt Klystron, 2.4 gigahertz.
Yeah, but to actually communicate, we've got to do a lot of special things with timing. We've got a maser time base, and we're actually coordinating with the Astronomy-Amateur group and with the group in New Jersey and with the group in the Netherlands, let's see, the Wick.
Wingaloo.
Wingaloo, is that right? Yeah, Wingaloo group. So they're going to try to receive our signal. So we've got 3 other 25-meter radio observer, 20 to 25-meter radio observatories that are going to try to hear our signal and record it. So that's all I've got. Any more questions?
Why not attempt a Mars signal bounce?
It's farther and it's less reflective. Venus is very reflective because the atmosphere is ionized. But Mars isn't. Mars is more like the moon. The moon and Mars aren't very reflective. But moon's real close, but Mars is much further out. That's about it. Wait, this year.
Maybe you could copy the signals from the some of the other equipment that's on Mars coming this way.
Yeah, when we do this, we'll probably document it and make a video of it. Okay. Well, I'm way over time. I'm going to let him get it back. All right. Thanks, guys.
Thank you.
It's